Over the past few decades, residential construction has changed dramatically. Homes today are built to be exceptionally airtight, wrapped in continuous air barriers, sealed with higher performance windows, insulated more thoroughly, and ventilated in controlled ways. These improvements make homes far more energy efficient, but they create a new challenge for fireplaces: supplying enough combustion air for the fire to burn properly. A fireplace cannot function without oxygen, and modern homes no longer leak enough air around windows, doors, and framing to naturally feed a fire the way older homes once did. This is why RCR 1006-2 exterior air intake becomes essential. As homes have tightened, fireplaces that once operated without issue now struggle to draft smoke into the room or fail to ignite properly. Negative pressure from kitchen range hoods, bath fans, and high-efficiency HVAC equipment can further starve the fireplace of air, pulling smoke backward into the house instead of allowing it to rise up the chimney. In many homes, the fireplace is not malfunctioning at all. The home itself has become too airtight to support combustion. Historically, exterior air intakes were optional components for prefabricated fireplaces. Manufacturers offered outside air kits, but for decades, most installers simply ignored them because older homes leaked enough air to feed the fire. As homes became progressively tighter, those incidental air leaks disappeared. A fireplace that once burned well suddenly began smoking and backdrafting, not because the chimney failed, but because the house no longer provided the oxygen the fire needed. This matters not only for draft, but also for combustion quality. A fire that is starved for air cannot achieve complete combustion. Instead of burning hot and clean, the fire smolders at a lower temperature, producing unburned hydrocarbons. These cooler, dirtier exhaust gases rise into the chimney with far less heat energy than a proper fire. Because the flue gases are cooler, they condense more quickly on the inner chimney walls. This condensation forms creosote, and the colder the gas, the faster creosote accumulates. In other words, an oxygen-starved fire directly increases creosote formation because incomplete combustion lowers the flue gas temperature, creating ideal conditions for creosote to condense and adhere to the chimney. Incomplete combustion also produces more soot, more particulate matter, and more smoke, combined with reduced flue temperatures. This can significantly elevate the risk of chimney fires. The problems all originate from a single source. Modern homes do not provide enough oxygen to feed the fire unless a dedicated exterior air intake is installed. Recognizing this shift, building codes evolved. RCR 1006-2 transitions what was once an optional installation into a mandatory requirement when specified by the appliance listing. The code acknowledges that the thermal and pressure characteristics of today's homes are fundamentally different from those of earlier construction. Without exterior combustion air, a fireplace will pull conditioned indoor air up the chimney, depressurize the home, cause draft instability, reduce combustion efficiency, and significantly increase creosote production. A properly installed exterior air intake provides a stable, dedicated source of oxygen directly to the fireplace. It allows the fire to burn hotter and cleaner, reduces smoke spillage, improves draft performance, and maintains flue temperatures high enough to minimize creosote formation. It also prevents the fireplace from competing with the home's ventilation and HVAC systems. In short, the exterior air intake reintroduces the oxygen balance that older, leakier homes provided naturally, but that modern homes no longer supply. As energy-efficient construction continues to advance, the need for exterior combustion air will only increase. IRCR 1006-2 reflects the realities of modern building science. Without proper combustion air, a fireplace cannot burn cleanly, safely, or efficiently. For inspectors, builders, and chimney professionals, understanding this connection between airtight homes, fire temperature, combustion quality, and creosote formation is essential to ensuring a safe and predictable fireplace system. Fireplace panels, often called refractory panels or firebox liners, are among the most critical components inside a prefabricated fireplace. Although they appear simple, these panels serve several important functions. They protect the thin metal shell of the firebox from direct flame contact. They help reflect heat back into the room. They stabilize firebox temperatures, and they maintain the tested clearances that keep surrounding combustible framing safe. In short, the panels are part of the system that allows a prefabricated fireplace to pass UL testing and earn its listing. When they fail, the integrity of the entire firebox and the safety of the adjacent building materials may be compromised. Manufacturers of prefabricated fireplaces acknowledge that refractory panels may crack over time due to repeated heating and cooling cycles. Most installation manuals include language discussing cracks, acceptable crack widths, and whether repair or replacement is appropriate. Many specify that small hairline cracks are normal and do not require immediate action, while wider cracks or cracks that separate material require attention. However, interpretation varies widely among technicians, manufacturers, and inspectors. In the field, chimney professionals repair cracked panels in several ways. One common practice is to use high-temperature refractory mortar to fill or patch cracks. This technique can restore surface continuity and prevent flame penetration, but it does not restore the structural rigidity of the original panel. Others may choose to replace the panel entirely using aftermarket cut-to-fit refractory panels, often made of ceramic fiber or molded refractory material. These aftermarket products are widely available and marketed as universal replacements for OEM or original equipment manufacturer panels. The problem is that there is ongoing debate in the chimney industry about whether these repairs violate the fireplace's UL listing. Some experts argue that the fireplace was tested and listed with specific factory panels of a certain density, thickness, and thermal conductivity. Replacing them with any material that was not part of the original UL test changes the firebox characteristics and therefore violates the listing. This group insists that only OEM panels should be used, and if OEM parts are no longer available, the fireplace should be condemned or replaced. However, others in the field take a different view. They argue that as long as the replacement panels are refractory, of equivalent thickness, installed correctly, and offer equal or greater flame protection, the firebox remains safe. They also note that the International Residential Code contains provisions allowing the use of aftermarket materials when original parts are no longer available, provided the replacement parts are considered suitable for the intended use. This creates a gray area. The code allows flexibility, while UL listings demand strict adherence. This conflict leaves chimney professionals in a difficult position. Some manufacturers do allow field replacement with aftermarket panels under specific conditions, while others prohibit it entirely. Some building departments accept aftermarket replacements without question, while others enforce OEM-only replacements, and consumers are often unaware of the implications or the safety considerations involved. What remains clear is that fireplace panels are not cosmetic. They are structural, thermal, and protective components integral to the safety of the appliance. A cracked panel can allow excessive heat to reach the outer metal shell, which can in turn overheat the surrounding wooden framing. Even a small defect may lead to temperature changes that the appliance was not designed to handle. Whether repaired or replaced, any modification must be approached with a full understanding of the fireplace's listing, the manufacturer's instructions, and the applicable building codes. Ultimately, the best approach is to verify whether OEM parts are available, follow the manufacturer's guidelines whenever possible, and ensure any field-installed panels meet or exceed the fireplace's required thermal performance. When uncertainty exists, a qualified professional should consult the local authority having jurisdiction or refer directly to the manufacturer. In all cases, the safety of the homeowner and the integrity of the fireplace system must take priority over convenience or cost. One of the most dangerous and misunderstood modifications made to prefabricated fireplaces is the installation of masonry fireplace doors over the front of a factory-built unit. At first glance, these doors can look elegant and give the fireplace a more traditional appearance. Homeowners often believe they are simply upgrading the look of their fireplace, but behind that decorative improvement is a serious and sometimes life-threatening hazard. Prefabricated fireplaces are engineered systems, tested and listed as complete assemblies. Every component, from the firebox panels to the front trim and even the louvers, is part of a carefully balanced design that manages heat by controlling air movement. When a heavy set of masonry doors is installed across the front opening, that delicate balance breaks. Factory-built fireplaces rely on an air-cooled circulation system that draws room air in around the face of the fireplace, moves it across the metal cabinet, and releases it back into the living space. This airflow acts as a cooling blanket around the unit. It protects the metal shell from overheating and prevents excess heat from reaching the wooden framing and combustible materials surrounding the chase. Much of this airflow occurs at the very front of the fireplace, around the trim, the lower and upper panels, and the area where the chimney collar connects to the firebox. This cooling system is not optional. It is integral to how the unit was tested, how it earned its UL listing, and how it keeps the home safe. When masonry fireplace doors are installed over the front of a prefabricated fireplace, they block the critical air passages that allow this cooling system to function. The doors seal off the front of the unit, trapping heat inside the firebox. Temperatures begin to rise rapidly. The metal shell overheats. The factory-built chimney system experiences temperatures it was never tested for, and the combustible framing around the chase is subjected to levels of heat the listing does not allow. In some cases, the firebox panels crack under the strain. In more severe cases, the framing inside the chase begins to carbonize. If the misuse continues long enough, these units can and have ignited house fires. This situation is not theoretical. Fire investigators routinely trace home fires back to improperly installed masonry doors on prefabricated fireplaces. The average homeowner has no idea that the decorative doors they purchased at a big box store or online are not compatible with their factory-built unit. They assume all fireplace doors are interchangeable. They are not. Masonry fireplaces and prefabricated fireplaces operate on completely different principles. One is built to absorb and store heat. The other is built to shed and disperse heat through airflow. Mixing components between the two systems creates a mismatch that undermines the fireplace's safety certifications. This is why it is critical for chimney technicians, home inspectors, and installers to check the type of doors installed on any prefabricated fireplace they encounter. If solid masonry doors are present, the unit must be evaluated immediately. The technician should verify whether the manufacturer specifically approves the door model. Almost no manufacturer approves masonry-style doors unless they are designed and listed for use with that particular fireplace model. In the vast majority of cases, the doors are aftermarket additions that must be removed to restore the fireplace to safe operating condition. A prefabricated fireplace is not just a firebox made of metal. It is a complete, engineered, air-cooled system. Blocking its airflow is far more dangerous than most people realize. When masonry doors are improperly installed on these units, the fireplace can no longer regulate its temperature. The result can be cracked fireboxes, overheated chimneys, damaged framing, or catastrophic structural fires. For these reasons, verifying the presence and suitability of fireplace doors on a prefabricated unit should always be part of a thorough inspection. Recognizing this hazard and educating homeowners about it can prevent untold property damage and save lives. The damper area and the collar-to-liner connection of a prefabricated fireplace are among the most important places to evaluate when determining whether a unit has reached the end of its safe service life. This is the point where the firebox transitions into the chimney system, where temperatures are the highest and where the stresses on the metal components are the greatest. Every prefabricated fireplace is a UL-listed system, tested as a complete assembly rather than a collection of independent parts. The firebox, the damper, the flue collar, and the chimney piping all function together as an engineered system. When one part fails, particularly in the damper or collar area, the entire listing is compromised, and the system must be treated as unsafe for continued use. Most prefabricated fireplaces carry only a 20 to 25-year limited warranty. These appliances were never intended to last indefinitely. With age, heat cycles, moisture intrusion, and metal fatigue, they eventually reach a point where deterioration becomes unavoidable. Much like an aging automobile, a fireplace can continue to run long after its prime, but that does not mean it is safe. Industry professionals differ somewhat in their opinions about when replacement becomes necessary, but the general consensus places the realistic maximum lifespan of a prefabricated fireplace at about 30 years. After that point, the risks of hidden deterioration rise sharply, and replacement becomes a prudent recommendation. NFPA 211 offers clear guidance in Section 14.9 regarding liners. If a chimney liner has softened, cracked, warped, or otherwise deteriorated, the standard requires that it be repaired or replaced. With prefabricated fireplaces, the liner is not a standalone component. It is part of the UL-listed system. When the liner deteriorates, there is no approved method for selectively replacing only the damaged portion. The entire fireplace and chimney assembly must be replaced because the original listing cannot be preserved through piecemeal repair. The top of the firebox near the damper is typically the first part of the system to show distress. Many technicians encounter what they assume is normal surface rust in this region. In some cases, the discoloration truly is moisture-related corrosion, often caused by a leaking chase cover or flashing failure. But in many other cases, the rust is actually the result of high-temperature oxidation. When the fireplace is subjected to temperatures beyond the limits it was designed and tested for, the steel undergoes chemical changes. Instead of ordinary rust, the metal forms a brittle, flaky oxide layer. The surface darkens, the metal weakens, and the structure begins to lose integrity. This is not simply cosmetic deterioration. It is evidence that the firebox has been overheated, either from a creosote ignition, overfiring, or another high heat event. The difference between normal rust and high-temperature oxidation can often be seen in the color, texture, and behavior of the metal. Ordinary rust from moisture tends to be more uniform in color and appearance. It sits on the surface and generally retains the shape of the metal beneath it. High-temperature oxidation, in contrast, appears darker, often black or blue. It flakes, scales, and becomes brittle. The metal may warp, thin, or crumble. When this type of damage appears around the damper opening or collar connection, it is one of the clearest signs that the UL-listed system has been compromised. Whenever this type of deterioration is observed, replacement of the entire prefabricated fireplace is the correct recommendation. An overheated or oxidized firebox can no longer be considered safe, and there is no approved repair that will restore it to its original listing. Homeowners are often surprised to learn that this type of damage may be covered by insurance if it can be shown that a high heat event caused the deterioration. Insurers commonly treat heat damage as direct physical loss, similar to other fire-related claims. Proper documentation from a qualified technician can help establish the cause and justify replacement of the unit. Ultimately, prefabricated fireplaces are not permanent fixtures. Their useful life is limited, and once they begin to show deterioration around the damper or the liner connection, the safety of the system must be questioned. When the metal in these critical areas begins to change composition, weaken, or crumble, it is no longer functioning as part of the tested and listed assembly. Recognizing these signs and recommending full system replacement protects both the home and the occupants, ensuring that the fireplace continues to operate within the safety parameters it was originally designed for. Installing a wood stove insert into a prefabricated fireplace is not allowed unless the specific insert and the specific prefabricated fireplace have been tested, listed, and approved together. A prefabricated fireplace is an engineered and UL-listed system, which means its firebox, chimney, cooling air passages, and clearances to combustibles all work as one assembly. Any alteration to that system, such as adding an insert that was not part of the original testing, voids the listing and compromises safety. Wood stove inserts operate at significantly higher temperatures than traditional factory-built fireplaces are designed to handle. Inserts produce hotter and more sustained flue gas temperatures, reduce airflow within the firebox and chimney, and increase radiant and conductive heat transfer. A prefabricated fireplace that has not been tested under these elevated conditions can overheat surrounding combustible framing and create a fire hazard. For this reason, neither NFPA 211, the International Residential Code, nor any fireplace manufacturer allows an insert to be installed unless the system was specifically designed for it. The only time an insert may be installed in a factory-built fireplace is when the fireplace is an HT-rated unit that has been UL tested with that exact insert model. In these special systems, the manufacturer provides documentation confirming which insert models are compatible. If the insert is not explicitly listed by the fireplace manufacturer, then the combination is not a listed system, and its installation is prohibited. It should not be approved by inspectors. It voids the fireplace warranty and safety listing, and it exposes both the homeowner and technician to serious liability. Insurance companies may also deny claims following a fire because the system was installed outside of its listing. In short, a wood stove insert and a prefabricated fireplace must be UL tested together as a pair before they can be installed as a safe and legal system. If they are not tested and listed together, the installation is not permitted and should never be approved.